Morning students. Today we are going to take next topic of applications of derivative. It is increasing and decreasing functions. Students, how can we find out that the given function is increasing or decreasing? So students, let I be an open interval contained in the domain of a real valued function f. Then f is said to be increasing on I if x1 less than x2 in I, then fx1 less than equal to fx2 for all x1, x2 belongs to I. Students, if we take two values from the interval I and in these values x1 less than x2, okay, and the value of function at x1 is also less than x2, then the function is called increasing. F is said to be strictly increasing on I, strictly increasing student, if x1 less than x2 in I and fx1 less than fx2 for all x1, x2 belongs to I. Students, if two values are taken from the interval I, x1 and x2, and x1 is less than x2, then also the value of fx1 less than fx2 for all x1 and x2 belongs to I, then the function is called strictly increasing. Okay students. Now students, if f is said to be decreasing on I, if x1 less than x2 in I and the value of function at x1 is greater than equal to the value of function at x2 for all x1 and x2 belongs to I, then the function is called decreasing. Students, if we take two values x1 and x2 from the interval and x1 is less than x2, but when we put the value of x1 and x2 in the function, then the value of function at fx1 is greater than fx2, then the function is called decreasing. F is said to be strictly decreasing on I if x1 less than x2 in I, but the value of function at x1 is greater than at x2 for all x1, x2 belongs to I, then the function is called strictly decreasing. In short students, if we will take two values x1 less than x2 and the value of function at x1 is also less than equal to x2, then the function is called increasing. And if we take two values x1 less than x2 and the value of function at x1 is also less than the value of function at x2, then function is called strictly increasing. Student, if we take two values from the interval x1 and x2, x1 is less than x2, but the value of function at x1 is greater than or equal to the value of function at x2, then function is called decreasing. And student, if we take two values x1 and x2, x1 less than x2, but the value of function at x1 is greater than the value of function at x2, then function is called strictly decreasing. So these four conditions which I told you just now, there is no derivative. Without derivative, we can easily find out the function is increasing or decreasing, strictly increasing or strictly decreasing, student, in these four conditions. Now students, first order derivative. You can see there are 4 points in which I told you the function is increasing or decreasing, strictly increasing or decreasing without a derivative test. Now students, first order derivative test. For checking the function is strictly increasing, strictly decreasing, increasing or decreasing. So now in first derivative test, let f be continuous on AB and differentiable on open interval AB, continuous on closed interval AB and differentiable on open interval AB, then f is called increasing in closed interval AB if the value of its first order derivative at x is greater than 0. Means f dash x is greater than 0 for every value of x where x belongs to closed interval of AB. Second students, f is decreasing in closed interval of AB if the value of function at x, the value of first order derivative of function at x is less than 0 or each value of x where x belongs to closed interval of AB. Means if f dash x less than 0, then function is called decreasing. Student, next point, f is a constant function in closed interval AB if derivative of function at x equals to 0, where x belongs to closed interval of AB. If f dash x equal to 0, students, on closed interval, then the function is constant function. If f dash x less than 0 on closed interval, then the function is called decreasing. If f dash x greater than 0 on the closed interval, then the function is called increasing. Okay students. Now students, if f dash x greater than 0, for each x belongs to open interval AB, then f is strictly increasing. Similarly students, if f dash x less than 0, for each value of x where x belongs to open interval AB, then f is called strictly decreasing function. Okay students, so this is first derivative test, student. So remember, if f dash x greater than 0, where x belongs to open interval of AB, then f is called strictly increasing. If f dash x means the value of first derivative of the function is less than 0, where x belongs to open interval of AB, then f is called strictly decreasing. Okay students, so these are the points at which we can find out the function is increasing or decreasing, strictly increasing or decreasing by first order derivative test. Now student, let us try to understand the function by the help of graph. This is the graph, student. There are points A, B, C and D. So students, you can see the graph. Graph is going up at A, when the value of x is increasing, then the value of function is also increasing, and the tangent at a is going up. Okay, it shows the function is increasing at a. So students, at point a the slope of tangent is positive, then f is increasing. Okay students, now students, you can see at point c the graph of function, the curve is coming down when the value of x is increasing, the value of y is decreasing student, and the slope of tangent at c is negative because it is coming down student. So we can say at point c the function is decreasing. So students, at point c the slope of tangent is negative, therefore the function is decreasing at c. So by the help of graph student, by drawing tangent at the point, if the slope of tangent is positive going up, then the function is increasing at that point, and if the slope of the function is negative, the slope of the tangent is negative at the point, it is coming down, then the function is decreasing at that point. Now student, you can see point B and D. At B and D, the slope of tangent, or you can say the tangents, are parallel to x-axis. Means their slope is 0. Then it is constant function. It is neither increasing nor decreasing student. Okay, so by the help of graph we can easily find out the function is increasing or decreasing, or it is constant. Okay students, okay then, have a nice day.